The webinar is aimed at showing some practical examples for the use of bioeconomy in sport. This initiative is part of the BioECO-UP project, which is funded by the Interreg Central Europe, which is a European Union program that supports transnational cooperation. The goal of this project is to make Central Europe more resilient to changes that represent global challenges that no single country can address alone. And specifically for the BioECO-UP project, the challenge is to adopt the principles of the circular bioeconomy and implement policy support measures for the bioeconomy. The concept of the bioeconomy is, in very general terms, aims to replace fossil resources with renewable raw materials in many sectors. And the goal of the BioECO-UP project is just to spread this concept throughout Central Europe. Today, we have delegates from companies of various sizes, from small to large, companies which have bio-based products in their portfolio used in the various areas of sport. The program begins with a presentation on the role of the bioeconomy in sport, given by Professor Chiara Samori, University of Bologna. Then we'll have a presentation by Dr. Martino Colonna, who is the CEO of Resport, which applies the principles of the bioeconomy and of circular economy in the production of materials for sport. Then we have a presentation by Dr. Gabor Gramsberger, CEO of Climate Action, which is a company which provides practical advice to customers and help them to develop carbon neutral management. Then you have the delegate from Arkema, which is a large chemical company which is producing and developing processes for the synthesis of bio-based monomers and polymers for the textile industries, and so even for sport. And the presentation will be by Dr. Thibaut Savard. And finally, we have the delegate from Bio2 Materials, Dr. Artur Bartkowiak. And Bio2 Materials is a company which turns biological waste into sustainable materials that replace traditional and synthetic options. So again, thank to all of you for participating and for giving your contribution. Now, I think that we can start with Professor Chiara Samori and an overview of the role of bioeconomy in sport. Please, Chiara, you can share the screen, of course.
Thank you, Fabrizio. Thank you for the introduction. Good afternoon, everyone. I'm Chiara Samori from the University of Bologna, and I would like just to spend a couple of words for introducing the topic of the webinar of today. I hope you can see my screen in the presentation mode. Is it visible for everyone? Okay, thank you.
Yes.
So just a couple of concepts and a brief sum up about the situation in terms of bioeconomy in sport. So the state of the art and perspective in this field. It's important to introduce that for understanding the framework of bioeconomy in sports, we have two different approaches that are often combined. First of all, the concept of bioeconomy. So the use of renewable resources for producing materials, clothes, and sportswear, but also energy for feeding sport event. And there is also the concept of circular economy in sport. And in this case, it is important to underline that it is always an important pillar of sustainability, but not often matching with the bioeconomy concept. Circular economy in sports can be seen in terms of use of waste or dispose items for producing new items, closing the loop of the materials. For what concern the different fields in which bioeconomy and circular economy can play a role in sport, we can speak about footwear and sportswear, so producing shoes and sportswear with bio-based material from different resources, renewable resources. And at the same time, the same renewable resources can be used for producing equipment for different kinds of sports, for example, biodegradable tennis string or balls or fibers for softballs and so on. But also these kind of materials can be exploited in the development of eco-friendly infrastructures, like for example, stadium and arenas composed by wood biocomposites, or the use of organic turf in stadiums and arenas. And last but not the least, the use of green energy for sport event, like for example, the use of biogas from the organic waste or the use of solar energy for through photovoltaic technologies. For what concerns the use of bio-based and circular approach for the development of sportswear, one of the nice examples that is possible to find in the literature is represented here in the slide. You can see here a pair of shoes made by Adidas using PET bottles and nylon fishnet, so waste plastic material that can be found in the ocean, collected and recycled for preparing this kind of shoes. And for each pair of shoes, it has been estimated that 16 PET bottles and 13 grams of recycled nylon have been used. But why these two different polymers, PET and nylon? Yes, surely they are among the main polymer that we can have in plastic waste, for example, in different kind of environments like ocean. But they are among also the few polymers that can be successfully recycled through mechanical and chemical approaches. PET in particular can be collected quite easily and separated from the other kind of plastic. And almost the entire composition of PET collected from the waste stream can be upgraded or recycled in different end product. For example, here you can see that 1/3 of the PET that can be recycled is used again for producing bottles. Another third can be used for producing film, and about 20% for producing textile. This figure is related to a mechanical recycle of PET, but it is important to underline that PET is one of the few polymers that can be also recycled by using a chemical approach. So producing a completely new polymer with the same characteristic of the virgin material without losing mechanical and physical-chemical properties. The other polymer that is popular in the field of sportswear is nylon. And also in this case, it is possible to recycle nylon by using polyamide, by using a mechanical approach. But there are also in this case some example of chemical recycling plants dedicated to the depolymerization and repolymerization of nylon 6 and nylon 6,6. And this approach is quite popular also in the field of sportswear, material for sportswear. Here you can see a list of some of the examples of sportswear that can be found in the literature. You can see that there is a variety of material from organic cotton to bio-based PE or recycled and bio-based fibers. A lot of possibilities for introducing bioeconomy in the field of sportswear. It is important to underline that the textile industry is one of the most impactful industry among the human being activities, because a very, very small fraction of the huge amount of fibers feedstocks, virgin feedstocks that are used for producing textile are actually recycled. You can see here the figure of this industry, and it is important to underline that the majority of the feedstock used for producing textile is nowadays sent to the landfill or incinerated. Just a very, very small portion, less than 1%, is recycled for producing again fibers. A huge amount of material, virgin material, is lost during the production, and the data that is important to take in mind is the huge amount of microfibers and microplastic that is released every year in the environment through different kinds of leakage. In particular, I would like to underline that each time we use a washing machine, so each time we wash our clothes, we generate microfibers, and in particular for each loud recycle, we produce more than 700,000 microfibers that correspond more or less to 0.1, 0.3 grams of microfibers per kilogram of textile. Which is the fate of these microfibers? They are entrapped, captured by the wastewater treatment plant in the wastewater sludge. So they are trapped by the wastewater treatment plant. And just a small amount are directly released into the environment and into the ocean. But it is important to remind that the end of life of wastewater sludge is often in the agriculture. So this sludge, full of fibers, full of microfibers, are put directly in the field, and here they can migrate in the water ecosystem or translocated in plants, creating a huge impact. Huge impact because the majority of the fibers that are released from textile are non-biodegradable. Here you can see, for example, that nylon and PET required a huge amount of time for being fully mineralized in soil and in the ocean. More than 100 years in the case of soil for nylon and 200 years in the ocean, and even more for PET. Surely, cotton and cotton microfibers are really highly biodegradable, so it's not an issue in terms of persistency in the environment. But it is important to remind that the cotton production has a very huge environmental impact because cotton requires a huge amount of water for being cultivated and a huge amount of pesticides. Even if cotton crops occupy more or less 2.5% of the global cropland, the cultivation of cotton requires more than 16% of the global agricultural pesticide. So it has a very huge impact. Moreover, not only in the step of cultivation, but also in the step of processing, because, for example, the cotton dyeing process required a huge amount of energy, chemicals, solvents, and produce a lot of waste. So cotton production and cotton fiber production is a very impactful process. And from this impact, it is necessary to think also to a sustainable way in which we can produce cotton, for example, by producing organic cotton that use a definitely lower amount of pesticide. Bioeconomy can be applied not just in sportswear, but also for producing bio-based sport equipment. And the Brazilian company Braskem is one of the leaders in the production of bio-based polymers, drop-in polymers, like, for example, the bio-based polyethylene or bio-based EVE, ethyl vinyl acetate. This process is well known and consolidated and starts from the conversion of sugarcane into ethanol, then dehydration of ethanol to ethylene, and then polymerization of ethylene to give the desired polymer, bio-based polymer. There are many examples of the use of bio-based material for sport equipment, from bio-based composites to bio-based polyethylene, to recycling of nylon fishing nets for producing different kinds of equipment, like, for example, battles or rackets or balls and so on. And the same holds for the development of circular solution and bio-based solution for infrastructure. Braskem was a partner of Polytan, the company Polytan, that produce bio-based synthetic turf system for the Olympic Games in 2024. But there are also other kind of options, for example, the use of reusable cups, plates, and single-use packaging, or the use of, for example, bioenergy to feed the power facility and all the events that are organized in a sport arena and stadium. So with this, I have concluded. I want to underline that sport can be made more sustainable by integration of bioeconomy and circular economy concept. Nowadays, there are very nice examples, and I'm sure that in the webinar we are going to listen many of them. And it is something that can improve the sustainability of a sector in which sometimes is not so often to think in terms of sustainability, but it is a good screen also for the young generation. I have concluded. I thank you for your time, and if you have any question, I'm here for answer to all of you.
Thank you very much, Chiara. Thank you very much, and especially for having focused on the main problems which are associated to the use of plastics. And the alternative is, of course, the bio-based plastics, which, however, have to be also degradable and compostable in order to be really sustainable. So thank you very much. And maybe we can keep questions at the end and for the discussion. Now I would move to the second speaker, who is Professor Martino Colonna from Resport. And I would ask to the speakers to stay within the 10 minutes of presentation. So maybe we can leave some time at the end for the discussion. So please, Martino.
Okay, thank you, Fabrizio. I share my screen. Let me know if you can see it. Do you see it?
Yes, yes.
Okay, perfect.
You can put in presentation. Perfect. Very well.
Okay. So I'm Martino Colonna. I'm a professor at the University of Bologna, and actually I founded here a lab called Sport Technology Lab that works in the development and testing of sport equipment. So I'm working in this field since almost 20 years, and during this period of work with several companies that are located in Italy, in Europe, and also in the United States, the company started asking us not just to develop the most efficient and with high performances materials and also new design and new concepts, but also to be more sustainable. And the request was so high that we started a spin-off company 3 years ago. And this spin-off company is called Resport. And I will show you today some of the projects we are running in the development of the recycling process and in the scale-up of the processes. So as been underlined by Professor Samori just a few minutes ago, the sustainability of a material and of a sport equipment in this case is connected to a lot of factors, from the type of material you are using at the beginning. So we will see example of bio-based materials, for example. In sport equipment, one of the first application of the material from Arkema, the Pebax, was on ski boots, actually, for ski mountaineering. But all the parts from the production to the use of the scraps during the production and the design also have a deep effect on the sustainability of the sport equipment. Today we just focus on the recycling processes. That is one of the main issues that we are encountering during as a big effect on sustainability of sport equipment. And the reason is pretty clear. Sport equipment was not designed to be recycled. It's been designed to be safe, to be have high performances, good look, and low cost. So everything is connected of many parts that cannot be, of course, recycled together. So if I'm recycling one plastic material, I cannot do mechanically with another one. So our aim was to find solution for this kind of complex systems, and we apply different types of recycling depending on the type of material we are going to recycle. And these are just 4 examples of European projects we have been involved in, and we did the proof of concept part, and then we are working the scaling up of these processes. We have processes from recycling of ski boots to skis to helmets and to shoes. The aim of this project was not just to prove that it was possible, but also to develop an industrial process. So in the case of the ski boots, there are already thousands of ski boots in the market made of recycled material. In the case of the shoes, 15,000 shoes have been just produced last month and be commercialized soon. So the aim is not just do the kind of research on the possibility to do it, but also to implement it in industrial scale. In several cases, what we found as an interesting approach was what we call selective dissolution. Selective dissolution use mainly natural solvents to dissolve and permits the separation of different materials. So in the case of the helmet I will show you, we did dissolution using bio-based solvents obtained from the skin of the lemon, the molecule called limonen, and they dissolve selectively one part. And in this way, then we can filter out the rest and purify it and obtain, we don't have a chemical depolymerization degradation of the polymer, we obtain the polymer pure as itself. So what is the advantage of this kind of solution? Of course, it costs more and is more complex than mechanical recycling, but mechanical recycling on system complex like sport equipment is quite difficult because of the high number of different types. But the respect of classical chemical recycling, that is a depolymerization or degradation of the main polymer chain of your material, the dissolution just breaks the weak bonds between the chains, so it's not affecting the macrostructure of your polymer. And also the plants are quite lower cost. So I just make you an example of how we did it from the low scale. And in case, for example, of the helmet are mainly composed of 3 polymers. So it's expanded polystyrene, EPS, ABS, and polycarbonate. ABS and polycarbonate for the outer shell. So we find that there are some solvents like limonen that are effective just to dissolve the polystyrene, and other like ethyl acetate, also bio-based, is able to dissolve ABS. So we started working with a company in Sicily that do in large scale extraction of limonen, and actually they are making it for like a flavor and for other purposes, and so it needs to be really pure. So all the waste they had from this limonen was good enough for this solution, but not could be sold for other, like for flavors applications. So this is just an example of the what happened if you try to recycle. This is a commercial motorcycle helmets. We cut it in 2 parts just to show the process. So we started the dissolution in limonen. Dissolution occurs at room temperature in around 10 minutes. So that is a little bit accelerated, but the dissolution is very effective. And so what you get at the end of this part, I just go a little bit on, then you obtain the outer shell that can be made of ABS, polycarbonate, of composite material, and then all the other parts are easily separated by filtration. So you can see all the foaming part for the cushioning, internal cushioning, all the connection part, and so on. Then since most of the helmets, especially motorcycle helmets, are made of ABS, we use another bio-based solvent, ethyl acetate. And in a little bit longer time, but still at a low temperature, 40 Celsius, we had the dissolution of the full dissolution of the ABS. Then by solvent evaporation and by filtration, then solvent evaporation, we recover. These are all the coatings on the helmet. And what you get at the end is a pure polymer and a series of three pure polymers. And just to show you, these are the three materials we obtained, and the mechanical properties were actually really close to the one of the virgin material, and that's because you had no degradation. But then the thing is, you need to scale it up to an industrial scale because the properties are good, the process is simple, but still we need to scale it up. So first thing was a small pilot plant that was able to recycle 5 helmets and a day, and then we recovered the material and we made all the calculation about the amount of energy, the amount of solvents you have to use, and all those data were then, of course, the solvent should be reused in other dissolution processes. Other way is not economically and environmentally feasible. But then the thing we did was a technical economic analysis and also a design of the plant, and that's what is the main work of Resport, is designing the recycling plant. And by this complex system, then we designed a plant that is now being built in Italy, and actually we should be start operating at the beginning of 2026, probably in January. And there is already a take-back campaign organized by major brand Dainese and AGV, that is an Italian brand, and now you can go and give back the helmets for its recycling. Similarly, we have developed other processes for the recycling again by using bio-based solvent like ethyl acetate, and we use for recycling of skis with a brand called Focal. And again, now we are scaling it up to a plant that should be able in 2027 to work on 10,000 skis a year. This is just a quick overview. If you want to have details on the project, they are available. There are websites that describe in detail the process. Another process that use bio-based solvents and mainly water in this case is this process we have developed along with Scarpa, and is the recycling of end-of-life leather shoes by hydrolysis and dissolution in water of the leather that is then recovered to create new shoes. This is a short video. I don't know how much time I have left.
Just no more than a couple of minutes.
Okay, 2 minutes is fine. So this is just the process. We have recovered 15,000 shoes in shops. Then we have dissolved the leather in a plant that we have designed and now is operating and makes 1,000 shoes a day in Tuscany. And so with the collagen and with the chromium we recover from the leather, we do the tanning of new leather without using chromium and other agents. So we reuse all this material. And then with the textile part, we grind it and we do agglomeration to create new footbeds. Then with the sole part, we grind it, and we had a technology developed together with a company in Italy that encapsulate in a new sole all the scraps of all the sole, all the grinded sole, and with the film on the external part, and then the rubber part is devulcanized and revulcanized. And now 15,000 shoes are being produced, and now they are getting to the market, just to show you that these kind of things are possible. Just last thing, and I'm over. We also working on textile for sport dissolution. Again, here we use selective solvents, for example, to remove the elastan from mixed fibers. In this case, we also do it on in women's stockings, but also in sport textiles, in which we use a bio-based solvent called dimethyl lactamide to dissolve selectively the elastan. And now there is a plant working on 4 million, we recycle 4 million stockings a year in Golden Lady plant. And also this can be applied also to other cases, for example, the tennis balls, to nylon with using water, ethanol, calcium chloride solution, and so on. So just this is an overview of a lot of possibilities you can have on in this field, and that can be scaled up. And I think there's just some of them. There are even more, and I think that's the key point of this kind of recycling is to reuse the same material in the same field of application. Not maybe the exact one, but in the same from the same companies, just to create a really fully circular effect. I hope I was not too long. So thank you for your attention.
Thank you, Martino. Thank you very much. This beautiful example of combination of the bio-based solvents, bioeconomy principles, and circular economy. Very interesting. Thank you very much.
Thank you.
Now we have the presentation from Dr. Gremsberger of Climate Action. I hope he's still on. I was.
Yes, now it's okay, I guess.
Okay, great. Thank you.
Yes. So
you have to share the screen. You have to share the screen or just.
Yes, I'm going to share my screen. Let me. Okay. Now it's. Can you see it?
Yes. Maybe in presentation mode is better to see.
Yes, absolutely.
Okay. Thank you very much.
So thank you very much. Firstly, thank you very much for this invitation. I really appreciate it, and also it's always nice to have these kind of meetings because if we are talking about sport and sustainability programs in sport, then a lot of people from sport and sport directors just try to catch up the topic, and we have to really understand how they are thinking, and we have to really explain in a way of the language of sport. So firstly, let me introduce myself. I'm Gábor Gremsberger from Hungary, and I have a company which called Climate Action, and we have one very big and very good focus industry, which is sport. So we have we have a lot of sport and sustainability programs. We are working with sport federations and sport clubs and associations in several ways of sustainability, like social sustainability, financial sustainability, and also environmental sustainability. And one of our first and very nice project was the Legacy Forest, which is a very unique one because at that time we Hungary organized the World Athletic Championship here in Budapest, and as you know, this is the third biggest sport event in all over the world. So the first one is the Olympic Games, the second one is the Football World Cup, and this is the third biggest sport event. And the CEO of the organizer, he was very motivated to do some environmental program and do some legacy for the event. The motivation for him was to do something because the event it was like 10 days or 8 days, but he would like to do some projects which is a real legacy for the event. So that's why that's how we found this Legacy Forest. And this project is several ways very unique, and also belong to environmental project, and also it's really focusing on biodiversity. So what is Legacy Forest? This is a urban forest. I can tell it's not the middle of Budapest, but it's in Budapest. So it's very unique because it's in a capital city of Hungary, in a fourth district. This is a forestry which around this 10 hectares forest, there are a lot of block of flats. So this is the green area of these people who are living there. The total area it's 9.81 hectares, and the idea was to work together with with the Hungarian National Forestries, work together with the company of the organizer, and of course climate action. And we just have a support from the Hungarian National Forestry, who gives us this 10 hectares, and this area is from the Hungarian National Forestry, from the Hungarian government, but takes care the Hungarian National Forestry, and we found these 10 hectares, and we would like to renovate these 10 hectares. That means we did change the 10 hectares, the bad and the sick type of trees we took off, and we changed and put new 5,000 seeds every hectares. That means we develop the biodiversity of the area. We develop the biodiversity of the forest, and we change the biodiversity. So it was very good for the nature, and it was very good for the people around, and it was offsetting project of the full event, because we calculated the carbon footprint of the full event, and it was the offsetting project of the event. Yeah. So it was a carbon offset project. It was climate resilience project. It was focusing on biodiversity. It was it was also effect on the community. So it was a little bit a social sustainability project as well, because this project effect on the area, and this project effect on all people around. Yeah, the environmental impact was, as I mentioned, we put 5,000 seedlings per hectares, and we calculated after with the University of Sopron. This is a Hungarian university for forestries, and this activity offset 303 tons of CO2 from the air. So actually, it was not the biggest project. Of course, we cannot offset all the carbon footprint of the big event, but it was a nice activity, and it was more for showing how we can cooperate, how we can link sport to environmental sustainability. How the project works. We planning it's a long-term project, of course, because we did it for long term, and that's why it's called legacy forest. So planting trees, maintenance, and monitoring all the area. So now we are making a yearly report to the Hungarian Athletic Federation, but we are really close connection to the World Athletics, which is the International Athletic Federation, and we send them every year a new report about how it is, what it is. We are going there, make some photos, and I can tell, especially now in Hungary, it's raining. So, but the trees are really growing, and now we can see and we can realize where did these actions in the forest. The project has some benefits, of course, for supporters. So we did it because of the social sustainability. We integrate not just the organizer company, we integrate also some sponsors from the event. For example, Mondo. Mondo is an Italian company who made the pitches and the running tracks also. So they also invested in this project. We asked all the big sponsors from the event, and we asked also some athletes from the event. And it was very nice because when we finished the championship, after I think after 1 month, we made let's say a ceremony there, and we invited the president of the World Athletics and also the sport director of World Athletics was here, and we planted some trees together, which was very, very fun, and a lot of sport athletes came and support us. So it was more communication, but it's also a good example how we can promote this kind of projects through sport to the people. Yeah, as I mentioned, we have some exact numbers about the project. So the summary of the project is it's almost 10 hectares. It's 5,000 seedlings per hectares, 303 tons offset, and yeah, the location it's in a forest district in Hungary, and yeah, this project is designed for life. It's a lifelong project, but of course it's like let's say we are calculating with the offset around 100 years. Yeah, it's just a fun fact of the project. Why join now? So you can join now because some clubs and some people and some company always looking for this kind of projects in Hungary and all over. Like we are working in 8 countries now, and they are always looking for this. We have another example which called Telekom Veszprém Forest. It's also very nice because one of the best Hungarian handball team, which is one of the best in Europe, we also made a project together, but it's close to Balaton Lake in Hungary, and it's almost the same. Of course, a little bit different because we plant different kind of trees, but there also we are working together with the National Forestry, Bakony Erdő ZRT, and also using the land of the government and land of the country, and calculating everything and monitoring everything, which is very important because then we can see the results and then we can measure the results, what and how we can do. Yeah. The next steps I already spoken about. We are monitoring. We are doing good communication for this project, and we are still looking for every project new sponsors, new companies, new clubs, new federations, because these projects it's not limited projects. So I mean, in one project can be 1 hectare, but we can establish 2 hectares, 3 hectares, 4 hectares, because we have a lot of this kind of forestries. Which we never would like to cut it down, but if we can refresh and if we can develop the biodiversity, it's always good and always nice for the country and for Europe as well. Yeah, so this was my presentation about, and of course, if you have any question, just let me know, and I can answer for it.
Thank you very much, Gabor. This very interesting example and very interesting information. Now we move on. Maybe we can keep the questions and discussions at the end of the presentations. Now we move to Arkema. Dr. Savard.
Yes. Hi, everyone. I'll share my slide right away.
Okay, yes, we can see it. Thank you very much.
Great. First of all, thank you for the invitation, as the other speaker said. So I'm Thibaut Savard, I'm business developer for sports in Europe. And so today I'm gonna present you the following topics. So a short introduction on Arkema company. Then I'll present you the bio-based value chain as we see it and as we propose it. Application of bio-based fibers such as the Rilsan P11 in textiles, its properties and technical positioning, also a circular solution that we propose, and finally a sum up. So to start with Arkema, we are a high performance material company. We like to say that we are dividing into 3 main segments, which are the coating solutions, adhesive solutions, and the advanced materials, which will be the main topic of today. And barely it represents a third each of our income. We are a worldwide company, as you can see on this map. So we are a French company, but growing and having plants and R&D center all over the world. The R&D is very important for Arkema, as you can see. It's more than 1,800 researchers, over 21,000 plus employees. So R&D, and especially regarding our high performance polymers, is something that we are really focusing on. We propose a differentiated portfolio of high performance polymers compared to our competitors. We mainly focus in the high performance and ultra high performance, as you can see on this diagram. Among these, I think the most interesting today that I'm going to present you are the bio-based products, which are written in green, so the PA11 and the PBAX. And I'll go deeper in details for this. Just want to mention that we have also other solutions, such as the polyimide that we recently acquired in Korea. Bio-based value chain. So as I said to you a few seconds ago, we have some bio-based polymers, and they come from what we like to call the magic bean. So it's the castor seed. There's a picture on here. And as you can see, it is a seed that grows, that we grow mainly in India, and does not need to have a very rich soil to grow. Actually, it's mostly the contrary. Also, it does not compete with food, which is very important to develop something that makes sense for the planet. No deforestation, and also highly profitable for the farmers. But even I would say on top of that, what is very interesting is that with that seed, barely half of it, 45%, we get some oil out of this seed, but the rest of it we crunch it, and it is used as a soil fertilizer. So we use everything in the seed, but what I present here is that we use it mainly to produce bio-based polymers. So we have the plant, the castor plant. We take the bean, we extract the oil, and then with a bit of magic and chemistry, we produce the PA11 polymer. The story is a bit the same also for the PBAX that one of the presenters also mentioned, that is used a lot in the sport and leisure industry. So thanks to those seeds and polymers, we produce bio-based, low density and very performant Rilsan and PBAX polymers that are used in plenty of applications. Here you can see that fabrics, textile, and industrial separation are a very important topic for us, and I'm going to present you more in detail. Here is just a sum up of what I presented on the seeds and on the way we see the development of bio-based solutions and bio-based polymers. And so since it's a bio-based polymer and does not make everything easy, but we also focused not only providing something that makes sense in terms of performance and being bio-based, but also we worked a lot on reducing its carbon footprint. For example, for the PA11, you can see here, compared to different fossil-based polyamides, such as the PA6 and PA66, for examples, but some others. We were 3 years ago barely 50% less than this, and you know that the last percent are always the most difficult to achieve, whatever it is. But we reduced up to this year to only 1.3 kilogram of CO2 per kilogram of PA11 being produced. So it's a huge achievement, but we don't want to stay here, and we still want to be at something close to 1 kilogram per equivalent of kilogram of PA11 being produced by 2030. The story of PA11. So the textile is finally the first application of PA11 in 1947. Initially, the market was in France and dedicated to the stockings and the tights production. So it was really a rather selective and luxury-oriented segment. But then it stopped end of the 60s. Because finally the competition against PA6 and P66 was not possible because they were lower cost, and the performance, the very high performance of PA11 was not necessary anymore for such applications. So it stopped at that moment for the textile industry. And so we tried to develop some new activities with the having high interest on using a high performance polymer. But barely since 2020, I would say, and we have renewed our efforts in textile development. And so we were revisiting the first application, as you see. So developing fibers, PA11 based, so 100% bio-based, to compete against PA6 and PA66 mainly in those applications. Just give you a short overview of the performance of those PA11 fibers that are bio-based against the competition. So it has been mentioned the PET that is widely used as PE, also polyester, so in the textile industry. As you can see on the left graph, the density of PA11 is really, really lower compared to those short chain polyamides, I would say, and even more compared to PET, 25%. So you can make lighter textile compared to this. Another important point is the moisture uptake, because one of the advantages of the polyester, obviously, is that it does not take a lot of moisture. So when you are wearing a t-shirt or something, it does not get wet. And it's also the case of the PA11 fibers, which is not the case of those short chain polyamides PA666 that are really sponges. And you always have the feeling of being moist when you wear those t-shirts. So that's one thing based on mostly on the chemistry, but the other thing is, okay, you'll wear some textile, and what about the use of that? And one of the very important tests, as you know, is the Taber abrasion test. So something that reflects the durability of those textile. And in that specific test, you can see that PA11 is really overpassing the performance of the PA6 and the PET, which is not that good in those conditions. Last but not least, it has been mentioned in previous presentation that yes, you create microfibers during the washing and so on, but not only. If you buy a textile that then is expanding or is changing its shape after plenty of washing, it's not good because you need to buy more of this, so it's less sustainable. Here, I just want to prove that if you do a burst, so that could represent the deformation after wash in wet environment of some textiles. The performance of a dry versus wet fiber is less in those two cases compared to PA6. So you'd better have those to have a more durable t-shirt, for example. But also what you like to do, especially in the sport industry, is to be able to have some nice heat transfer over time through the textile, so you don't feel too warm during some sports. And in that case, polyester is really worse compared to the PA11. For some application, sometimes it's not only for sports, but also for the automotive industry. They like to have some cool touch or something. And in that case, also PA11 is better than the other polymers. Circular solution, just want to mention that in 2021, we acquired the company Agiplast. So it's an Italian company that is really a specialist of recycling advanced polymers. And thanks to Agiplast, we can offer new polymer grades, new high-performance polymer grades. Recycling, so doing only mechanical recycling in our case. Recycling plenty of polymers coming from different sources. For example, the virgin material manufacturing, some polymer being processed, or also some end consumers parts that can be then recycled to make new products for new applications. So it can be both in circular, in closed or open loop, sorry. But we know, and it's been mentioned also in presentation, that for the textile, it's sometimes difficult to do a closed loop. And so to remake a new textile out of the recycled polymers. I'm almost done with this presentation. Just want to sum up in this table. So that P11 as a textile is 100% bio-based with low density. So it's a lightweight material. Does not take too much water compared to its competitors. And you can have a nice abrasion and chemical resistance, and also a nice feeling when you wear it, especially as a sportman. It is not only on the paper that it's a success, this P11 as a fiber, it has really an industrial application at least. So we are working together with Radici, also an Italian company, that launches the Biofill 11, which is the textile fiber made from this unique polymer. And here is an example of a dress being made with those fibers, and different ones. So in the footwear industry, in the sportswear, also toothbrushes, very nice and funny application sometimes. So just in this 10-minute presentation presents you how much I can, but yeah, feel free to ask questions and ask for some more details. Thank you for the attention.
Thank you very much, Thibaut, for this very nice example of a successful industrial exploitation of the bioeconomy principles. So by the way, this is the field of my research interest, so I'm very interested in this presentation. Thank you very much. And now we have the final presentation by Professor Bartkowiak. Sorry for the pronunciation. And the company is Bio2 Materials. Please, yes. Professor Bartkowiak.
Yes, I will just a moment. I will start. Okay. Can you see my screen?
Yes, perfect. Yeah.
Okay, thank you. Good evening. As I was introduced, my name is Artur Bartkowiak, and I'm a co-founder of Bio2 Materials company. And today I would like to present some of the general information and maybe a little bit of story of our company and final product, which is called Nutica, which is for us, it's a next generation of circular material, which is should be as similar as possible to natural leather. From the background, I am polymer chemist, and I also, I'm sorry, I don't know why. Okay, now I see. Okay, the company, how the story starts. It's together with my colleagues Ola and Katarzyna, who are the architects, and they actually 7 years ago they were actually their idea is what it was to find solutions for food waste and turn those food wastes into the products which will be similar to the leather. We are located in Warsaw. We have our own laboratory and also research facilities there. And our product goal, it was of course the alternative leather, and we succeed actually to develop the so-called chocolate leather. And that's the reason why it's called Nutica, because it contains from, of course, chocolate, but also from some wastes from the nuts. Just a moment. What was our philosophy from the beginning? I think that there are 4 pillars for us, very important. One is, of course, people, biomimicry, waste, and locality in terms of the sources of the materials. And we succeed actually to bring people from both, not only from universities, but also from R&D centers. And we have a collaboration with the industrial partners already from the beginning. Of course, we look on biomimicry as example, or also try to find the best solutions and to see how develop the new products which will be 100% bio-based and also biodegradable. The, of course, idea as from the beginning, it was to turn some of the agricultural wastes and industrial byproducts into high-value materials. And it's very important to also mention that if we're talking about the LCA or some other issues, those products, even if they are wastes, they should be locally oriented. Okay, and the story. The story starts from the apples, and we for 3 or even 4 years were developed and were focused on apples as a pomace, which is one of the main byproducts from the production of the apple products or apple itself. And Poland is one of the biggest producers of the apples. And we focus on try to use those byproducts, but unfortunately there was some issues. For example, it was high water usage, and of course demand of the energy for drying. And one of the even bigger issues was low microbiological stability. And finally, we succeed to obtain the material, but unfortunately, we had still to use not bio-based polyurethane. And of course, now there are some bio-based polyurethane, so-called, but still they are not biodegradable. But our goal, it was to use actually fully, or to develop fully biodegradable material. Therefore, we look further and we look for another process. And both of us, Alexandra and myself, we are from Szczecin, which is a northwest part of Poland. And we have actually one of the oldest chocolate production facility here. And they have, as a byproduct, the cocoa husks. And we select one of these products as a material, but also we select another one is ground walnut shells. And this one is from Ukraine, and probably some people do not know that Ukraine is one of the biggest producer of the walnut in Europe. And the final compositions of the product that we develop is thermoplastic biopolymeric elastomers filled with both of those natural byproducts, cocoa husk powder and walnut shell powders, plus some additional additives. The process, we use the thermoplastic process. It's probably it's 2-step process. First, it's formation of the granulates by extrusion. And the second step is a typical cast process where we cast the biocomposite directly on the cotton or some other fabrics that it's selected. And finally, after those 8 years or 7 years, we were able to succeed, and the product is on the market from June this year. We have achieved the TERL of 9, and we are able to produce actually 2 products. One is 70 and the second is 140 products with in a rolls form, where the bottom layer is either textile. It was mentioned today, maybe it's not the best organic cotton, maybe it's not the most in this case ecological. Therefore, we also use the another as the potential. It's a tensile lyocell, which is based also on the fibers, on cellulose fibers. What is actually our main also the issue that we address? We do not produce all colors. We just use only the natural colors, which means we use either the natural colors which came from chocolate or from the husks or for the walnut. And secondly, for some to have red colors or so on, we use the inorganic pigments. And as you see on the right side, we have different texture. This texture is made by the thermo reversible process, which is normally made in a leather industry, which is called calendering. And finally, the product itself, first of all, is biodegradable, it's durable, it can resist up to 100,000 of specific bendings, which is very important for the textiles or for the products like the leather. And there is also very important that we do not use any of either PVC or polyurethane. It's 100% biodegradable and based on the bioresources. And last but not least, we succeed. Actually, we have started some collaborations, and we are able to show some footwear products, clothing, accessories, also furniture applications, and recently also we were able to, or we are working on flame retardant materials, which are can be used for interior design. And still we are open, and we are just now starting some collaboration with the automotive industry, and maybe based on also on today the seminar, we will be look for some sports accessories and other technical products. For us, it's very important that we just not only sell a material. We together collaborate with our clients, because working with leather or leather-like materials, you have to imagine that it's a process. It's not something that you sell the product like a material, but it's a design, and it's a long story that it's still in front of us. And that's all from my side. I think very important. If you are interested and if you like to somehow use our materials or test our materials, please contact my colleagues who are responsible for the this technical part, or not. Sorry, I'm for selling. It's Marta or Joanna. And if you have any questions, I'm of course will be very happy to answer to these questions. Thank you very much.
Thank you very much, Artur. Thank you very much. You have seen a few examples, successful examples of applications of the principles of bioeconomy and circular economy from different countries in Europe, from France, Poland, Hungary, and Italy. Very nice overview. Now there is some time for questions. If there is any question from the audience. If not, I have a question for all the speakers, very general questions. I would like to know from you, which are, in your opinion, the main obstacles, problems that may limit today the application of the bioeconomy principles in industrial sectors like sport or whichever other sector. And how do you see in the next 5-10 years, for example, the role of bioeconomy in industry? So you can start from Martino, and then we go to the other speakers.
From my side, what I've seen as a main problem is, especially for the end-of-life products, the collection and all the permits you need to move and to work on waste. And so that's a part that is quite, until the EPR scheme is not out from the EPR community, I think that is a main issue. And because in our projects, actually, we thought that the collection and the take-back campaign was the easiest part of the project, and instead it was not. And also for the permits to start new plants that maybe use some technology that have not been yet developed in other cases is kind of difficult. So that's, in my case, that's the most difficult part.
Okay, thank you. Gabor?
Yeah, I think in sport, like sport industry is really a well-developed industry, but I think one of the most active industry because fans and sport athletes and all the clubs has to follow everything day by day. So and also they are really motivated to reach goals and that kind of stuff. So I think in at least next 3 years, but life is getting faster and faster day by day. At least next 3 years, I think all the middle clubs, federations, and up to middle class and federations have to do some kind of things, some kind of sustainability projects, some kind of calculations. It will be a must for them. So I think it's a good this area and this industry has a lot of potential, but now the time is to collect clients and start to do as much as you can pilot projects and that kind of stuff. So I think it's this industry has a lot of potential in a sustainable way as well.
Thank you. Thibaut?
Yeah, so I think there's always a confusion in the consumer also between bio-based, biodegradable, and things like that. And sometimes bio-based can be associated to lack of performance. So this is something we fight against, not every day, but almost. As it has been proved, I hope in my presentation, it's not the case when we work really properly. So it also is the case, to my opinion, when we do proper recycling and we provide some then proper materials adapted to the needs of the customer. So I think it's worth it to continue educate people on this. Because that's, to me, the key, to educate the customers on what can be reached with something that is bio-based, especially in the sport and leisure, because there's on outdoor and so on, we know there's a special link with the nature and so on. So I think that's something we should also bring. Yeah, that's that has also to be the second thing is that has to be linked to the eco design of parts, not trying just to replace a fossil based or something part by just a bio-based polymer or bio-based part. It has to be rethought, and we can also help on that. And I'm sure plenty of the speakers today can help also.
Thank you. Arthur, any comment?
I think from our side, it's still the issue, it's time for entering the market, especially well developed with full of other materials. It's a question about the cost versus performance and versus standardization, especially standardization of the raw materials. We see this is a lot of drawbacks and challenges. There are not standardizations, especially when someone treat their end byproducts like byproducts, which means we have to, for example, in our case, to be in contact with the producer of specific products. I mean, for example, those cocoa or walnut of the nuts, and we have to give them indication how they should treat their waste products. And I think that's still it's a challenge that most of the people consider those materials as really as a wastes, not as a potential materials which can be used for further applications. Thank you.
Yes, yeah. Thank you very much. I definitely agree with the comments, and especially the one from Arthur. It is unbelievable that there is no law in Europe which allows to clearly distinguish in the label of the product that it is made from a bio-based and not from petroleum. And this is really something which should be, in some way, a problem which should be solved. There is a question now from Laura. Laura, please, Laura.
Yeah, thank you. Thank you for the great talks. They were very interesting for us. So my question, in a certain way, has been already touched, because I was curious to know if there are differences among countries in terms of perception by consumers. Do you think they are ready to buy products, bio-based products for sport, even if they are more expensive than perhaps other, or we still have to educate them, or us also, because I think people are ready to buy for sport, to spend money for sport, for sportwear in general, but I don't know if they are educated to know which can be the difference between a bio-based product and the others.
Yes, who is going to reply to this question?
I can try partially to answer that. In our case, we propose high-performance polymers, bio-based, that are overperforming some others. So just developing some tests and products to show that it's for just comparing apples and apples, a bio-based polymer can be really overperforming a non-bio-based polymer is already something. And sometimes when I think about recycled products, it's not always, first of all, lower performance. Okay, can be, and after, depending on the number of recycling cycles we are applying and so on, that's for sure. But it can be also cheaper than the raw material. So for dedicated application, sometimes we cannot assess with the raw materials, bio-based or not. But in the case of bio-based, and sometimes it's affordable with recycled materials. And here I'm not speaking about safety parts, because there's also in mind that recycle is not something that is safe enough compared to the raw material. So something else we need to educate, but that's at least our point of view in that field.
Yeah. Myself, I think that in Poland, it's still people they are ecological when they are interviewing or interviewed by someone. The moment they enter the shop or whatever, they think differently. Or I think that's also, it's education is very important. And I believe that still this is the margin. Even if someone tell you that he or she is going to buy bio-based product, finally in the end, if she or he will compare the price, probably is going to decide to go for not really bio-based. And I think still it should be they have the same performance, the same price. If not, then after that it will be always there are some people who never decided to buy this. Yeah, I fully agree. I'm working a lot on the development of new products, and so when they ask me, and I give the advice of using a bio-based or recycled material. At the end, the first question they ask me is will be the price the same or not? Because then they are not going to sell it. And even in the United States, that's a big issue because people don't want to spend more, and also is afraid of using recycled materials. Even if they've been tested and everything, they still don't trust. And in some cases, also for not just for the performances, but also for the look. So in some cases, I've seen examples in which they used some way to like hide the fact they were using recycled materials, especially in fashion industries, and I've seen a lot. And they just do it because then they can declare it in some way that they are environmental friendly, but they don't want the customer to know it because then the product is not the same level. So that's I've seen a lot of these kind of things in also in the sport industries. Even in companies, they are really think that is a good and they're really pushing, but they are a little bit afraid of showing it.
Yeah, but in a other way, like I think, of course, financial question is always very important, but sport is a real special word. So sometimes they don't really think about money. Like they just would like to be the first one. Like I have experience, for example, the last swimming world championship here in Hungary. They just said, let's do some sustainable report and program because we would like to win some award about that. So they have another motivation also. Of course, money it's a very big motivation, like the budget, but sometimes not in sport. That's my experience.
Thank you. Thank you. Now we have another question from Dr. Mike Silla.
Yeah, thank you. I have two questions actually. And first one to Martino. When applying selective dissolution technology you're talking about on an industrial scale, which poses a greater challenge, like establishing an effective collection and take-back system, or ensuring an environmentally viable solvent circularity?
That part is for me is more simple. I mean, I was talking about the take back because it's something I cannot control, and while the part in let's say the technical part is more let's say controllable in certain ways. So it depends a lot on the type of solvent you're going to use and if it's flammable or not flammable. So when we design the plants, there are a lot of things to be considered because they are industrial plants with the chemicals that can be flammable, even if most of the cases, actually all the processes I showed you, they are bio-based solvents, but they are flammable. So you need to take care of that. And also another really important thing is a way to recover it fully. So if the recovery of the solvent in the process is below 99%, then the process becomes not economically feasible. And so you need to find out some distillation methods, some separation methods also to recover fully the solvent. So that part is like drying the final material, precipitating, and so on is the more complex one. Dissolving is easy.
Okay, thank you. And my second question is to Artur. As Nautica begins scaling from innovation to wider commercial use, what do you see as the biggest challenge? Securing consistent, locally sourced food waste feedstock, or convincing fashion and sport brands to redesign products for truly circular, biodegradable materials?
I already said it's again it's long. We start the long process just We see this already after the first trades, or we were part in one of in Paris. And people, of course, like the idea. They would like to make some of their products out of our material. But this is, in most cases, at the beginning to show up, to make a lot of noise about that. But finally, we are afraid that we are not only on the market. There are some other companies, probably there are some companies which produce actually Mirum in US and so on, and they go to the bankruptcy. This is, I think, what we learn. It's time. We probably will need another 3 to 4 years before we'll be really could be not founded any longer. And now we have to talk to our investors, and this for us is a big challenge, to somehow to say to them, it's not the way that within the next 6 months or 1 year we can actually earn so much money that we can go to the position that we at least can be even can pay our costs, which means it's long, really, in the fashion industry, especially in the fashion, you see this on TV. You don't see so many people, regular people, who wear those kind of clothes with bio-based materials and so on, which means it's, again, as Fabrizio said, probably we need some regulations. European Union not only should give the money for the project, but at least change the legislation. I think it's even more important than our projects. And for the moment, this is the most, I think, important challenge for us, that how the market is going to be developed. And that's something that we have to face it.
Thank you.
Okay, thank you very much to all the participants. We have to close now. And it has been really quite an interesting discussion, and many different contributions, and not only in the field of sport, of course, but the focus has been on bioeconomy and circular economy. So I think it has been very fruitful. And I thank again all the participants, all the speakers, and the next webinar will be on construction, buildings, and furniture. It will be in 16 December, I think, and you are invited to attend, of course. And again, thank you, and see you on the next time. Bye-bye to everyone.
Thank you very much. Bye.
Bye-bye.
Bye. Thank you. Thank you very much.
Thank you. Bye. Bye-bye.